All right. Hey, everybody, and welcome back to the Expert Witness podcast. I'm your host, David Smith, and I'm here with Rob Irion. Rob graduated from BYU in 2013 with a bachelor's degree in mechanical engineering. He began his career in the oil and gas industry, developing new drilling tools that utilize synthetic diamonds. He then shifted to the medical equipment industry, developing more powerful and higher resolution MRI scanners at GE Healthcare. Before joining Alpine, Rob lived on the road with his family, traveling the country in a truck and fifth wheel trailer, during which time he did some freelance design work in the medical device and consumer product industries. Rob has been with Alpine Engineering and Design for about 2 years. Since joining Alpine Engineering and Design, he has acquired his Certified Safety Professional certification and is just finishing up his requirements to become a licensed professional engineer, expected later this year. He's worked on a variety of projects and cases such as exercise equipment, trailer design and analysis, industrial equipment safety, heavy lifting equipment, and patent litigation support. In addition to his engineering and expert work, Rob is also doing sales and marketing tasks for Alpine, which has been a fun and new challenge for him. Rob grew up in a large family, the fifth of 7 kids. He was obsessed with sports and Nintendo. Today he is married, has 3 young kids, and a dog. He enjoys basketball, rock climbing, fly fishing, traveling, and playing Nintendo to this day. Rob, welcome to the podcast.
Thank you, David. Yeah, good to be here.
We are happy to have you here.
Appreciate it.
So tell me a little bit about how you got into mechanical engineering.
Yeah, it was growing up, it all was just from a general curiosity about learning how things work. I remember taking apart a Super Nintendo controller to see how it worked, mentioning Nintendo before. But even as a kid, I had no idea how it worked then, but that excited me to realize that there was just so much to learn in this world, both in technology and just the world itself. And also as a kid, I was pretty rambunctious, and there were a lot of times where I was horse playing around the house and broke a wall clock or my dad's camcorder or my mom's exercise bike. And so as a method of self-preservation, I thought, okay, I better learn how this works, put it back together, try to fix it before I get in trouble. And in rare occasions, I succeeded. It didn't happen very much. Most of the time, it was a feeble attempt to fix the broken thing with Scotch tape or whatever. So I'd get in trouble most of the time, but sometimes I'd get away with it. So
I think anybody that's had young boys understands that difficulty. I know I've
yeah.
got 3 boys myself, so we certainly have been there. And if they could even try to put something back together, that's a win in my book.
Yeah, my nickname growing up, one of my many nicknames, was the human pinball because I'd just bounce off the walls and I'd inevitably break a lot of things. So trying to fix it was a nice way to get my engineering chops even from a young age.
Oh, that's great. So you spent quite a bit of time in the medical device industry. What drew you to the medical side of engineering?
It was what really lit that fire for me was my senior capstone project in college. We worked on a project. It was a neonatal ventilator for developing countries, meaning a ventilator for newborns that had to be reliable and inexpensive. And doing that project really opened my eyes to see that engineering could be a vehicle to really help other people. That not only was I curious about how the world worked, but I could use that to help other people live healthier, happier lives. And that ventilator literally saved lives. And so it was such a cool experience to feel that, I could use the vehicle of engineering to do some good in the world. And that was a great feeling. And just doing that then led to other engineering opportunities in the medical industry. I worked at GE Healthcare for about 7 years, working on an MRI, a new MRI, so research and development in that area. And also, while I was on the road, did some freelance work where I did some reverse engineering of auto injector pens, kind of like your Wegovy's and Mounjaros, the GLP-1 shots, reverse engineering those to figure out what made them work and doing other cases like that. And since being at Alpine, doing some work in the medical industry, like for example, a surgical stretcher failed during surgery, and figuring out what went wrong and why was a cool way to work in the medical field.
Absolutely. Uh, So have there been any technical challenges that you have overcome while working with medical equipment? I know that's really what engineers do, but is there a situation that stands out from your past that you could tell us about?
Yeah, there are so many, and that's one great thing about both the mechanical engineering side of what we do and also the expert witness side is getting to the root cause of a failure and seeing what could have been done to prevent it and mitigating that hazard moving forward. Um, let's see, when I was back at GE Healthcare, I was in charge of a project. It's a subsystem of the MRI. The MRI has a really strong magnetic field, and the gradient coil was the system that I worked on. It experiences a lot of G force, vibrational G forces because of that magnetic field. It's pulsing on and off, it's trying essentially to shake itself apart. And so it's our job as engineers to prevent that from happening. We were most of the way through our development process of this new MRI system when we had done multiple prototypes of the build, and suddenly new builds started tearing themselves apart when we were testing them. And so we had to do this deep dive into what went wrong and why, and not to get too much into the weeds, but the entire system had to be encased in epoxy. And so that means every single thing you put into that gradient coil, we really needed to make sure that it bonded well to that epoxy, because if any bonds were weak, then they would be the failure point, the initiation point of any cracks or delamination that would happen in the system. And so we realized through a lot of testing, a lot of investigating, that these large plastic sheets, essentially is what they were, the supplier we had been getting them from, unbeknownst to us, had switched up how they were sourcing their raw materials. And so the ability for those sheets to bond to the epoxy had changed. Nothing on paper had changed. We were getting what we had specified, but something that was previously unknown to us happened where these coils started tearing themselves apart. We realized what went wrong, and we were able to, after a lot of testing, like I said, a lot of investigating, understand and specify what needed to be present on these plastic sheets. Essentially, they needed to be more rough so that the epoxy bonded to them well, and other things. But it was just a great example of what engineering can do. We break things down. We try to we follow the breadcrumbs where they lead, and find that root cause and address the issue. And there's a lot of other examples like that in engineering, and that's one thing that makes me love what I do.
Yeah, that's great because products almost never come out the way you want them to on the very first try. There's
Absolutely.
always some amount of iteration and detective work to figure out why things aren't working the way you thought they would or the way you expect them to or the way
Mhm.
you need them to. So
For sure.
that's great. So now that you've been with Alpine Engineering and Design, what are some of the projects that you've worked on there, and what have you taken away from those projects?
Yeah, I've done a lot in trailers, both in the design and in analyzing and certifying different trailers to various standards. Amusement rides, done some work in the amusement ride industry, exercise equipment, industrial equipment, done some patent litigation support, and I love that that's such a wide variety. And I still get that same satisfaction of helping people through those projects as well. You know, it doesn't have to just be a medical device to be a vehicle to help people, helping people be safer or protect their intellectual property, pursue justice in an injury case, or just clearing up the facts of a complicated liability suit. That can be that same vehicle to help people in life.
Yeah, absolutely. So even though you're focused on medical devices, have you found that the variety working in different industries is helpful to you, or do you start to feel more like a jack of all trades, master of none type of person?
Well, yeah, so that's I wondered about that initially. And what's great about this work is I can carve my own path, become deep in the knowledge of certain areas and highlight that expertise when talking with attorneys. If it's not a dead bullseye, and if a case comes through the door and it's not a dead bullseye and something that I'm confident in, we have other engineers here that likely can work on the case. And so I enjoy the variety. It keeps that curiosity of mine piqued and it keeps things fresh. So I enjoy it. I think it's great that I can focus on a few areas, but there's also a variety inside there, which I appreciate.
Yeah, absolutely. I think that there are a number of factors for me that I find interesting working in a variety of different fields. For example, seeing how the same basic engineering principles apply more globally, where
Yes,
you're really doing the same things in a medical device industry and in the trailer industry and in exercise equipment. It's really the same mechanical engineering principles that you're applying just to a different subject matter.
that's true. Yeah,
Uh,
you break things down to their core aspects and characteristics, and yeah, it's just engineering in at its basic form. Yeah,
yeah. And the other aspect of that that I find really interesting is when you talk with innovation experts, they often highlight that combining multiple industries or having experience in multiple industries leads to more innovations. And so being able to pull experience and pull technologies from different industries and combine them together leads to better products, better designs overall. That's something that I have found.
that's true. The broader your knowledge, the more you can pull from. They might seem disparate areas, but really, yeah, you can take lessons learned from one industry, apply it to another. Yeah, that's true.
Absolutely. So, as this is the Expert Witness podcast, can you describe your expert witness journey so far, how you started and what your first cases were like?
Yeah. Yeah, right now I'm still trying to break in and get my first retainer. It's been a great experience still so far. I've just been a lead associate to other retained experts on their cases. It's been a great training ground because I feel my engineering skills are solid. It's nice to kind of learn the legal side of things, the expert witness specific side of things. And some early examples of cases I worked on. I think of the first patent case I worked on was it revolved around bearings. And even being a patented inventor myself, I was struck by the arcane language that can be used in patents and the documentation around patents. It's its own world. And the more I have swam in those waters, in the patent world waters, the more comfortable I've gotten with it. But that first one was a little shocking to see, like, oh man, I understand the invention, but all this language around it, it took some getting used to.
Yeah, that is interesting. And something that I also didn't recognize when I first started this is you can be a really good engineer, but there's a whole additional skill set that you need to learn to become a good expert witness. And how do
Hmm.
you take all of that engineering knowledge and apply it to to the cases and the projects that we work on in litigation support?
For sure.
So,
Yeah, for example, just when you're in a room full of other engineers, you can kind of like that patent language. There's almost an engineering language that you can talk to each other and kind of there are assumptions that you all typically agree on. And so you can build off of those. In working in product liability or patent work, you have to point to specific standards or regulations or industry norms. You have to point to those first and then build off of those, where you can almost skip that step if you're talking engineer to engineer. But in product liability, you have to really dot your I's, cross your T's, point to everything. Everything needs a reason. And that's just one muscle you have to develop.
yeah, there's kind of two aspects of that. One has come up several times on this podcast, but it's the idea of de-jargoning.
Hmm.
So explaining things without all the technical lingo and the jargon that engineers might use. And the other idea is, I think, very important in this work because it's not what you know, what you specifically know. It's
Hmm.
what you can show that the industry knows.
Yeah,
Right? And so
true.
being able to point to that in standards or textbooks or treaties, uh, those are all better ways of showing why something is important or why something was well known than just saying, I've always done it that way and I've always known it.
Right.
So, so that's great.
Absolutely.
So talk to me a little bit about certifications. You
Hmm.
recently earned your certified safety professional, your CSP.
Hmm.
You're working towards your professional engineering license. How do you think those credentials will impact your work and credibility?
Yeah, it is a way to showcase and bolster my solid engineering consulting work and also my expert witness work. Those credentials, the CSP, for example, informs my decisions when making designs, ensuring that they are reasonably safe. And also, speaking about the CSP, it's a framework for understanding and explaining safety principles, like we talked about, uh, de-jargoning and making things clear to a court or jury that, hey, we need these safety principles implemented in this design because XYZ, it needs to be laid out clearly and authoritatively. So pointing to that CSP and learning from the process of the rigorous training to get that certification is a nice framework to be able to come from. Like, hey, we have to make this safe, and these are the credentials that I've gained to show that I know proper safety principles. And for the PE, basically the same rules apply. They show that you have the technical knowledge that and the expertise in engineering fields, that you're not just doing the trust me bro. You're pointing to the PE and showing, hey, I've done the work. I can bring that Pasita's insight, that person of ordinary skill in the art, because I've gone through the training, I've gone through the education and all the certifications.
So I think most people know that not all certifications are created equal. Some range from, a half a day seminar and $50 and you have a certification to something that's much more involved. Can you tell me a little bit about what it takes to get your certified safety professional certification?
Yes. So, the one thing that's clear is that you need to know your different areas of safety. So there's a big pie chart of different safety topics. So fire safety, chemical, PPE, hierarchy of controls, and a lot of other safety principles that you need to understand well. And again, that will inform your design decisions or process controls. So just a lot of study. And then after you've studied sufficiently well and know your stuff, you need a degree as well. Also, you need to take what's called the ASP, the Associate Safety Professional Test, which is a 6-hour test, kind of touching on each of those slices of those safety pie, of the safety pie. And then after that, after you've passed that test, then you study some more. And then you take the Certified Safety Professional Test, which is another 6-hour test. And once you pass that, then you get your Certified Safety Professional license. But then it's not over because you have to do continuing education every few years. You have to do hundreds of hours of continuing education to ensure that you maintain that knowledge and that expertise.
Yeah, sounds like a great certification to have. Congratulations on passing all of those really long tests.
Yeah, thanks.
All right. So you also help with sales and marketing at Alpine Engineering and Design. That's something that I think most expert witnesses have questions about. But how does that complement your technical expertise?
It's been a fun challenge for an engineer like me because we typically in our studies and in our certifications we pursue soft skills like communicating well with prospective clients isn't usually at the top of our priority list. And so it's helped me to develop those and also to uh, put myself in the shoes of a potential attorney or prospective client. What would they, what are their pain points and how can we help? So we can be pretty nerdy as engineers and have those highly technical terms. So communicating well with prospective clients or attorneys is a skill that I am developing and feel like it's an important one to have. But it enhances your technical expertise because you can, I think in teaching someone a principle, you yourself learn it more deeply on a deeper level. If you can come at it from a different angle, explain it a different way, then you yourself understand it a little better. And that skill is necessary when trying to promote our experts here at Alpine. Each of us have different skill sets and expertise. And so showcasing those has been a fun challenge.
Yeah, that sounds really interesting. All right. So you've mentioned a couple times, and it seems like there's a common theme in your career that you really like to help people with your engineering. Can you explain what that means to you and how it drives your work?
Yeah, I remember a college professor telling us a story about when he was in a canyon that had a deep and fast running river in it. And there were a group of people playing by the river, and someone that wasn't a very strong swimmer had slipped into the river and started struggling and was being carried downstream. And he told us that the most of people in the group kind of froze and didn't know what to do. And so he was courageous enough and took the initiative to dive in, swim to the person, and saved him. And his story, he tells this story and then asks us, like, what kind of person do you want to be? Do you want to be the type of person that jumps in, helps someone? You have to ask yourself those questions before these scenarios arise. And while that's a dramatic story, it really sunk in that that's part of what life's all about, is helping each other. And I wanted my career to be a vehicle to do that. So it gives me a rewarding feeling at the close of a case or a project when I feel like, okay, I did what was needed to for justice to be served or for this product to be a safer one. And yeah, it's just a rewarding feeling.
Yeah, absolutely. That's great. Helping people, providing value, m- getting outcomes that are in accordance with the best engineering and scientific principles is very rewarding work. So I agree with you on that.
Hmm.
So Alpine Engineering and Design has a purpose of engineering to contribute to a just, fair, and safe world. How does your work reflect each of those values?
Yeah, that purpose statement is what drew me to work at Alpine. It's a place with people of integrity, and and I like breaking it down into the three parts. So it says engineering to contribute to a just, fair, and safe world. And each one kind of touches on a different aspect of what we do here. So just the word just applies to personal injury or product liability cases where if we can get to the root cause of a failure, we follow the breadcrumbs where they lead. It's a way to bring justice or to showcase the truth in a lawsuit. It's that impartial scientific approach that really appeals to me. Again, it feeds that curiosity of getting to what happened or how something worked or how something failed. And so that's the just part. And then the fair part, it relates to the IP or the patent litigation support that we provide, helping to provide a POSITA's insight into intellectual property matters. That is a way to help people to protect their IP, whether showing invalidity or infringement. And I love that that's an aspect of this, is helping people protect their inventions, their ideas. And then the safe part is just helping people do dangerous things safely. That's a fun way to approach engineering. That, technology is amazing, but sometimes it can introduce some safety risk. And so we can address those, make things safe for people so they can lead happier and healthier lives. So I appreciate that this work that we do here is a vehicle to do that.
Absolutely. That's great. Yeah, I agree that equipment should not only make the work easier to do, but keep the people doing it more safe
Mm,
as well. So
for sure.
I appreciate that. Rob, I appreciate your time today. This has been fun talking with you. should anybody want to contact you, what's the best way to get a hold of you?
Yeah, you can call us at 801-763-8484. I'll put on my sales and marketing hat. Or on our website at alpineeng.com. You can see my CV on there and ways to contact us. And so, or email me, and you can find my email on our website. My last name's a little unique, so I won't spell it out for you here. But yeah,
It'll be in the show notes.
it'll be in the show notes.
Very good. Well, Rob, thank you. I appreciate your time. This has been fun.
All right.
Good
Thank you,
luck.
David. Had a
Good
great
luck
time.
getting into this.
Appreciate it.